Hello. Okay, this may or may not be working, but we'll see what happens. Gosh, it doesn't sound like the amplifier's on, but that's okay. So welcome to the Tyler Amateur Radio Club. Oh, there it is. We're wired for sound. Firstly, first, I'm Wayne, WM5Q. I'm your unreliable president for this year somehow. Let's see. First, do we have any visitors here tonight? Any first-timers? Oh, would you like to introduce yourself briefly?
Thanks. My name is Craig Cook, and I'm W5CKP, relatively new hand. Been
Cool.
here in Tyler for a while, and we're glad to be part of the club. Just joined recently, so looking forward to it.
Well, we're glad to have you. Let's see. Let's see who. Oh, Garrett. Hi. Yes. Who are you?
I'm also a new hand.
Cool.
KJ5 MBB.
Well, cool.
Good to be here.
We're glad to have you. Any other visitors? Well, cool. Well, we're glad you're all here. Is the picture up there? Yeah. So there's a reason you're all here this evening, and I'm going to try to stand as little between now and then as okay. First thing, I guess. Let's see. Repeater report. The repeaters are working. So that's and that's a good thing because we use them. Josh, do we have numbers or numbers?
We have 123 active members in the club as of this evening, and $5,800 in the bank. No expenses to discuss at this point.
Hooray! Thanks. Let's see, Butch. Anything from the VE team that you want to talk about?
Last Sunday session, we got two new hands, a husband and wife team came in, got their license. And we started this week. It's the first time that I plan to be here at 6 o'clock on the regular hooky to offer testing if anybody wants to upgrade or bring the kids in.
Well, good deal. Thanks to you and the team for doing all that for us. That's great. And Joe, if you want to say anything about the loaner program, or now or later, whatever.
If you're a club member in good standing, and depending on the class of license you have, I have a bunch of radios out. I didn't bring the spec sheet on how many I have out, but I think I only have one HF radio left right now, and I didn't have a power supply, but I got one on order for that. So I do have one VHF radio that's available right now, but all the rest of them are loaned out. So, but if you need an HF radio or a VHF radio, I do have one of each. That's about it. I'll be tapped out after that. So there's a bunch of them out there.
Thanks, Joe. That loaner program is a great thing. Thanks for doing that, administering that for us. Let's see, a couple of upcoming activities. These are a little further out. You may remember there was some talk a few weeks ago about maybe doing a camping trip in the fall, like Halloween time frame. I haven't seen any talk about it very recently, but just reminder that's a thing that there's discussion about. Most of that has been on our Discord channel. You can find it from the club website. Also, Texas QSO Party is about a month out. Some of us are going to be doing a multi-op effort for that from KK5TY. That'll be weekend of September 20 and 21. So if you're interested in being part of that, coming out and see the multi-op thing and try to participate some, let me or Thomas or Andrew or somebody let one of us know, and there's going to be more talk about that as that gets closer. With that, is there anything we need to do before we get to the U2 and the things? Oh, Hamp.
I'm cleaning out some stuff, and I found some old handbooks, and I've got them there on the table, and if anybody wants them, there's I think a 61 or 72 or something like that. Not old, but just to browse through and toss them away.
Well, cool. Very cool, thanks. Yeah, give those a look. And I think that's everything important, all the business we got to do before we get to look at some really cool pictures. So, Joe, it's all yours.
Oh, thank you, Wayne. I'm going to need somebody to push the button for me. I'm going to go slide to slide. Yeah. So I got to get out front so I can see and read my writing because I don't remember everything. So anyway, I did this presentation maybe 3 years ago, and so I've updated it with a little more information and maybe a few more pictures and things. So we'll see what we have here. Oops, wait a minute. Well, oh, there it went. Oh, you got it. Oh, that's right. I can't do it anymore. Okay. The U-2 is a reconnaissance platform that has served this country since 1954. And initially, it was used primarily for Cold War strategic reconnaissance with film cameras and taped data. So it really had no live data going to the ground. And then later on, it began to be used for more tactical reconnaissance purposes, that you had some real-time line-of-sight data links. And today, and I've been out of it for probably 7 years, well, more than that, like 10 years, because I was on another program. But I think there's only one film camera in use, and so you wonder, why would they still use an old film camera that they've got to come back and develop? Well, the reason is that if say that we find out we've got to go to another country to do some kind of operation, and they hadn't been there in 10 years or 15 years, well, they don't have any maps. So things have changed. So what they do is they'll send a U-2 over with a camera, and they'll take real high resolution imagery, and they'll send it to the Defense Mapping Agency, and then they'll make maps so that the guys on the ground have maps up to date, because you don't want to go to a place that has a 10-year-old map. So that's about the only reason I know they use it for. And today, the U-2 is utilized for both missions. They can use a real-time data link, or they can use real-time dissemination to the warfighter or intelligence agencies. So we'll show you a little later how some of that data is sent out to the users. It's currently operated by the U.S. Air Force 9th Reconnaissance Wing at Beale Air Force Base in Marysville, California. And we'll see a little later, there's also a detachment that's been in Korea for as long as I remember, and they operate out of Korea all the time. And they're also usually deployed somewhere. I spent 3 years in Afghanistan deployed with them, and they're deployed different places around the world. So they keep talking about canceling them, but I think right now, the last I heard, they're supposed to be around for 2 more years, but they've been saying that for the last 10 years. So anyway, next slide. Okay, this is the ground station. This is where all the data comes down, either from a beyond line of sight data link or usually a satellite data link. And this is where all these operators, they look at, and they have people that analyze imagery, and they have people that are linguists, and then they have communications links where they can send that data to a lot of other places. Say if they need a particular linguist, they can do that, and then they can, they'll go back later and get real detailed information, but if they have real-time data that's in a tactical situation, they'll do what they call gisting the data. So they'll just read it real quick and get the gist of it and send out a message saying, they're saying do this or do that, or so you won't get the whole story, but it'll give you enough information that the warfighters need. So next slide. Okay, this is one of the few film cameras that we use, optical bar camera, and you can see what that looks like. It rotates back and forth like that. It goes in the nose of the U-2, I can't remember if that was in the nose or the Q bay. Then there's also some of the cameras with the nose and the Q bay, but it's been so long that I can't remember where that one went. But that's about the only one that they have left that I'm aware of. Next slide. Okay, the U-2's mission is to collect signals intelligence and imagery as part of the big intelligence picture. And so when they're up, they're doing both. They usually are collecting imagery data and sucking up all the radar intelligence data and communications intelligence data. And virtually all the voice and digital communications is encrypted. So they have to, National Security Agency is always trying to develop software to decrypt the information. So their big challenges is to have ways to decrypt that encrypted information that's continually changing, and the National Security Agency furnishes that software. And I guess if they don't have software that can do it, they can store it and do it later. But they're pretty good at getting it done in real time. And then also, once they get that encrypted or decrypted, of course, people in other places are going to be speaking different languages. They don't all speak English, so you also have to have interpreters. So you have to have voice interpreters that can speak a lot of different languages. So that's a specialty that the Air Force has, and they'll borrow people from embassies or other services that if they need a particular linguist, and they'll sit down and listen to that, and they'll make notes on the gist of what they're saying. Later, they'll get better information. So if you look at the big intelligence picture, the U-2 does a lot of signal intelligence, which is administered by the National Security Agency, and imagery data, which is the National Geospatial Agency and the National Reconnaissance Office. And of course, that also comes, they get information from satellites and other aircraft, things like that. And then there's also measurement data. So the Defense Intelligence Agency handles that because they, they'll see something on the ground, so they want to know all the dimensions of it and things like that. And so they're big into that kind of thing. And then, of course, human intelligence is done by the Central Intelligence Agency, and I've had the pleasure, I guess, of working with those people a few times and working for them on some projects. And they actually, my last deployment, I worked with the CIA, and we had a chef flown in from D.C. We had gourmet food, had great, I mean, it was awesome, better than working for the Army or anybody else. So, next slide. So why was the U-2 built? After World War II ended, the Cold War began, and the U.S. needed some information about what the Soviets were doing, just like we still do today. That hasn't changed. And so the Air Force selected Bell Aircraft and Martin to build a fleet of modified twin-engines B-57s, and they designate the RB-57. And the CIA was looking at that, and they said, well, that's not really going to work for us because it doesn't fly high enough, and it's too slow and doesn't have a long enough range, so they were looking for something else. Well, Kelly Johnson, who I knew personally for a while, right after he retired, I'd met him several times. I worked with the Skunk Works, and so he said, well, they were good at doing unsolicited bids, so he said, he calls up the CIA, said, I heard you guys need some more reconnaissance information, so they worked. I said, what do you need? And so they found up, so they end up decided to build a U-2. Next slide. So this was a picture of the RB-57 that the Air Force wanted to use, but the CIA decided it wouldn't do the job. Next slide. Okay, so first off, they built 24, they had 24 Skunk Works engineers that completed the design. Now get this, 8 months, and these were draftsmen working on drafting boards with pencils, running the vellum drafts down to the floor. You had people cutting metal, building jigs, and even making molds for castings. And they completed the first U-2A, made a flight in 8 months after they got the contract. That's unheard of today with all the equipment they have, but that's the way the Skunk Works worked back then. And so Tony LeVere flew the first flight on August the 4th, 1955, out at Groom Lake, better known as Area 51. And I have been there, and it's not very exciting. It's like the place we'd sleep in was like sleeping in a 1950s hotel room out in the middle of the desert. So I can say I've been there, but it wasn't much to write home about, I can tell you that. The U-2 was kind of unique. It had and still has a single main landing gear and a tail wheel. So when it stops on the runway, one wing falls down, and so guys have to run out there, stick a pogo on one side, then they push that wing down, stick one on the other side, and then they're able to taxi in. And so when it takes off, they taxi out with those pogos on, and they pull the pins on them. And when the weight comes off the wings, the pogos fall off, and the ground crew has to pick them up. Every now and then, one of them gets stuck, and that's not a good thing, because then they have to try shaking it a little bit and get it off. They don't really want to land with one of those, so every now and then that's something that sticks, so they try to keep those well lubricated. Next slide. And this is one of the first U2s, a U2A. And the main reason I put this up here is just to show you, because it had a good side view of it. So the configuration of the newer, more modern, larger U2s is kind of the same. You have a main landing gear here, and then you have a tail landing gear. And this tail gear is still the same one that they use, and it's actually a steel hub with a hard plastic base on it. And those things wear out, and when they do, they start coming apart, but they're not pneumatic. And I think the reason they're not pneumatic is because when you go to high altitude, it's unpressured, they'd probably explode, and so they make them out of rubber. So they or plastic actually, and they change those frequently, but they do last. And then if you notice on the end of the wing, there's a skid plate. It's kind of hard to see right there. You see that? So when it lands and starts to stop, it'll go down on one wing. Well, it hits that skid plate to keep from tearing the wing up. Then they'll come out and put the pogos on it, and then they can taxi it back in. Next slide.
Is the main landing gear pneumatic?
Oh yeah, the main landing gear. It's in a pressurized area of the yeah.
Oh, okay.
So the tires don't blow up. And this is an old U2A actually, but I just wanted to show you how this is a camera being loaded into it by a Lockheed maintenance crew. And so this is what they call the Q-Bay. And this hoist right there, they still use that hoist. There's different payloads that go in the Q-Bay. And so what they do, they roll it under there on a cart and hoist it up in there and bolt it into place and hook up all the cables and everything. So a lot of there's equipment in the nose and the Q-Bay and then pods we'll show you a little later. But the cameras and then now other reconnaissance equipment goes in that bay there. So that's one of the main bays where they put reconnaissance equipment. Next slide. Okay, some special requirements. U-2s, not like any other airplane really. So the pilot's got to suit up and breathe pure oxygen for an hour because they have to get all the nitrogen bubbles out of their blood. If they don't, they'll get the bends and it could really kill them, or they could have real problems. And we did. I'll go into this a little later. We had some problems later in the program where on some longer missions, some pilots over in Afghanistan were getting the bends and very painful. And so and when a pilot flies, they're on a special diet before and during the flight. They have to have a high protein to prevent solid waste. You can imagine why that is, because if you're in a suit, like the same suit the NASA astronauts wear, you don't want to have any solid waste issues. But they do have a relief tube for liquid waste. And missions could last up to 12 hours, so a pilot could be in that suit for a long time. Typically, they try to cut the missions a little shorter than that, but sometimes they have to be that long. So they suit up, and they had to pre-breathe oxygen for an hour to get all the nitrogen bubbles out of their blood. So they could be in that suit for like 13 hours before they get out of that sucker. And so it's being a U-2 pilot is not a real glamorous thing, I can tell you that. And David Clark built the pressure suits for the U-2A, and for later models of the U-2 and the SR-71, it's the same one the NASA astronauts wore. And the reason that they're in this suit is at altitude, you're at 60 to 70,000 feet. It's like minus 65 degrees F or less. And so the suit in the cabin is heated, and the pilots have to breathe pure oxygen so they don't get decompression sickness. And during the Gulf War, we were sending them on some pretty long flights, and so the pilots, we had several that did develop decompression sickness, and one of them almost couldn't land. They finally had to talk him down after several attempts, and so they finally decided, well, they needed to correct that problem. So what they did is they made some structural modifications to the cockpit, so they increased the pressurization from 29,500 feet to 15,000 feet, and that seemed to fix the problem that the pilots were having on the long missions. And so there's a special egress system in the U-2. So you can imagine you're in a spacesuit. Well, if you're at 60,000 feet and you bail out, well, if you weren't pressurized, you would explode. You would die immediately. So the pilot stays in the seat, and there's an oxygen bottle, and his suit stays pressurized, and so he falls for thousands of feet with a drogue chute, and when it gets to a certain altitude, it kicks him out of the seat, and then he falls a little further, and then the chute opens, And so then when he gets to the ground, he's got to get that helmet off pretty quick or he's going to suffocate. So you don't want to eject if you don't have to.
So, what was his name, Gary Powers?
Yeah.
He ejected like that?
Yeah, but they had the ejection seats. There was an earlier model airplane. The ejection seats weren't as good, and the suit was different. I'll show you some suits in a minute. And the thing about the U-2, it has what we call a coffin corner. So as you get up to altitude, when the air gets thinner, the speed of sound is less. So the speed of sound at lower altitudes is higher, but as you get at lower, it's higher. But when you get higher in altitude, the speed of sound is less because the air is thinner. So what happens is we call it a coffin corner. So if you don't have enough lift, the wing will stall, but if you get too close to the speed of sound, you'll get shock waves on the wing and it'll lose lift and fall out of the sky. So they have to stay within about a 10-knot margin. So there's an autopilot on the plane when they're flying at altitude, and it's extremely difficult to hand fly that airplane. They've done it a few times if the autopilot failed, but if the autopilot fails, you pretty much scrub the mission and go home because it's extremely difficult to stay within a 10-knot window and not either stall or overspeed the aircraft. I'll show you an example right after this. But when the U-2 lands, the nose is so big that when they flare and the nose comes up, they can't see the runway at all. So they have a chase car that chases them. I used to, when I was on deployments, I'd ride with they'd have like Mustang 2s or some hopped up car with some speed shops made them. So we'd get up to 110 miles an hour from the end of the runway and intercept the U-2 as it came down and talk them down. So got a few thrilling rides every now and then. So next slide. And this shows what I'm talking about. Here's a U-2 landing, and there's a chase car. So you can see that when the nose comes up, the wings are so big that you can't see to the side much. There's a little bit of area to the sides over here you can see, but in front of the airplane, the nose is so big with some of the equipment they have, well, he can't see the runway. So he has to have a chase pilot in the car flying and telling him, how high he is above the ground. He'll say, you're 10 feet, you're 9 feet, you're 8 feet, touch it down. And they talk them down like that. So, in an emergency, they can land and they just kind of have to feel their way to the runway, but usually they have a chase car on the bases that they operate out of. Next slide. Okay, this is the first pressure suit like Gary Powers wore. So this is made by the David Clark Company, and you can tell it's all laced up to tighten it up and everything. Next slide. This is the suit they wear today, and you may recognize that just like the NASA astronauts wore. It's a much better suit, a little more comfortable. It's not as tight, but it works well. But like I said, the pilots, they have to get suited up an hour or more before the flight, and they have to breathe oxygen for an hour to get all the nitrogen bubbles out of their blood. So once they lock that helmet down to start, they're in that suit for 12, 13, 14 hours before they get out of it sometimes. So next slide. Okay, the U-2, there were several versions of it. So the early U-2s, there was the A through the H model, and they were smaller. There were 55 of those built, and they had an 80-foot wingspan, about 50 foot long, and they had a J57 turbojet engine. And then they went 15 years with no trainer. So most airplanes, you have a trainer you can fly in. Well, a U-2 pilot, he puts his suit on, goes and flies an airplane for the first time. He's never been in one before. He may get on the ground some cockpit familiarization, or they had a mocked-up cockpit that showed the instruments, but actually flying one, they didn't have one. So finally, 15 years later, they did build some trainers where they had and I'll show you a picture of one in a little while, where they actually would have a instructor in the back, where the Q bay is in the back, and would be talking to the pilot, teaching them some finer points of flying the U-2. There were 12 U-2Rs built, and you can see the difference in the wingspan. They were 103 feet long and 63 feet long. And a U-2RT, they finally built some of those a two-seat trainer. And I think they built more than that. And then I was on a program called Precision Location Strike System for a while, where you had to have 3 U-2s that they're going to fly in over Eastern Europe or outside of Eastern Europe, and have 3 airplanes, and they would intercept emitters and triangulate them because you had 3 airplanes. So they built all these TR-1s. Well, then they canceled that program, so they had all these extra airplanes. Well, they just went ahead and used them for the regular reconnaissance activities, and they had one TR-1B trainer. There's 2 of those built, so I can't tell you. I mean, there's let's see, and all the U-2s, U-2Rs that were built later when they got the F-118-10 engine, which was a turbofan engine. The other engine was a pure jet engine. Then they redesignate them to the U-2S, and all the TR-1s, they had the old U-2Rs and TR-1s where when they updated them all, they changed them all to U-2S, and there were 24, it says there are 24 U-2Ss currently in service, and 2 trainers for 26. I know I heard that they did crash one of the trainers the other day, and they did put one aircraft that had a fire back in service. So is there 26? I don't really know because I'm not privy to that information in there, but somewhere around that, I'd say maybe 24 to 26 available right now. I just don't know for sure. Next slide. During the 80s, when they were going to do the 3 airplane thing, they opened up the production line and built a whole bunch of U-2s. So this is in Palmdale, California, Air Force Plant 42, and it shows you the final assembly and test area for the U-2s that were in production in the 1980s. That was the last batch of U-2s that were built, and they called them TR-1s then, and then you can see they later changed them to U-2s. Next slide. Okay, here's a busy slide. So there's a lot of stuff here. So there's a satellite data link on the U-2, and it's up in this radome here. That way, they can go up to a satellite and then down to a ground station, or go up to a satellite to another satellite, then to a ground station. So they can literally be flying anywhere in the world, and they can get their data by the satellite data link. And then over here, you can't see it, but right here there's a little antenna, like a whip antenna, and that's the VHF antenna. And then there's behind it that blade right there. That's a UHF antenna. That's what they use to communicate with air traffic control, just like most any aircraft has. Excuse me. And then this here is a line of sight data link. So if they're flying within range of a ground station, like for instance in Korea they have a whole detachment that's been over there for years and years, and they have their own ground station, and they have their own Korean interpreters and everything. So they can go directly to a ground station when they're flying, close enough, within a couple 100 miles away. But if it's further than that, then they have to go through a satellite data link here. And then these blade antennas on the bottom, you see the VHF ones, those curved ones, and there's some straight ones in there you can't see very well. So the big ones are the VHF ones, and there's some of the shorter blades are the UHF. So those are the comms collection antennas. And then normally in this pod right here, it's kind of hard to see. There's a flat radome on the side of the pod. Well, there's a whole array of spiral antennas, back cavity spiral antennas, and some horn antennas. And those are used to get very high frequency things, and then radar, mainly radars, are picked up by these antennas here. And the pod's exactly like this on the other side of the aircraft. So they can receive everything from VHF communications all the way up to microwave communications. And they call these super pods. And then the nose here can have a electro-optic sensor, which imaging sensor, or they can have a radar sensor. They have it's called an ASAR system. It's a synthetic aperture radar, and it pans back and forth. The nose rotates, and it takes radar imagery of the ground as they fly along. And it's not as good as a photograph, but it's you can distinguish vehicles, tanks, things like that. So they can cover a lot of ground and map it all out with an ASAR's radar type antenna. So there's different kind of noses. They can change mission profiles. They just change noses and reconfigure the aircraft with different reconnaissance assets. And then there's a thing called the Commander's Tactical Terminal. and usually it's probably on the pod on the other side. You might, I don't know if there's even one on there right now, but what it is, it's just a UHF blade antenna. And what they can do with that is if they're operating in an area where there's troops on the ground, the people back at the ground station at Beale Air Force Base or in Korea or whatever can talk back through the airplane and then go out this commander's tactical terminal and talk to troops on the ground, so they can get real-time reconnaissance data and feed that data to the troops on the ground in that area. They're within range, they're within line of sight range of the aircraft with this thing called a commander's tactical terminal. So it's really just a radio link that they can give them real-time reconnaissance data. So if you had a special forces group on the ground, or you had a reconnaissance group for whatever service, and they had a radio, they could be talking to those guys on the radio, and probably sometimes they wouldn't transmit much, they would just receive because they don't want to give away their position. So anyway, they have a way to communicate with people on the ground with the data that's analyzed back at the ground station. It comes back through the aircraft and it can be disseminated through the aircraft to people on the ground in real time. Next slide. Okay, the U-2ST trainer, it's the same aircraft as the UTS, except that they took where the Q bay is and they built another cockpit. They just took the top cover off the Q bay and they made this cockpit back there and have 2 sets of controls. So now the trainer, you can have a student pilot in the front and an instructor in the back, and they can actually teach better, and if the student doesn't get it, they can take over. Where before they had this, and in the old days, these pilots would go up for the first time with never been in one before, and it's a difficult airplane to fly at times. It's very difficult to land, and if you get at high altitudes, like I say, you only have a 10-knot window, so you'll fall out of the sky and the wings will come off of it. So nowadays they have trainers, and so they have a qualified, experienced instructor in the back seat back here telling the guy, don't do that, or oh, you're doing a good job, or whatever. So they talk them through it. So they have a lot of ground training and academics they have to go through, and then they get several flights in a trainer, and then they'll actually get so many different qualification flights in a regular U-2 with the different kinds of equipment on board. Next slide. Okay, this is an SA-2 guideline missile, which is a very old missile, but I just had a picture of that. I put it in here, and that's what shot Gary Powers down and some of the other people back in the day. They have much more sophisticated missiles than that. So nowadays, the U-2 can't really fly where missiles like that are, because they're even at 60 to almost 70,000 feet, they can still shoot them down pretty easy. So they don't fly in areas where they know there are missiles like that, so they'll make routes around it, but they can stand off 100 miles and still look in and collect data. So the mission planners take all the reconnaissance data they have, and they know where threats are by looking at the kind of radars they have and stuff, and if they have missiles and the range of the missiles. So they'll do the U-2's collection route where it's out of the range of the missiles, but yet they can still look because they're so high that they can see a long ways. So mission planners are very important because they plan the routes to keep the pilot out of areas of danger. Next slide. Okay, this is some significant events through the history of the U-2 program. 4th of August 1955 was the first U-2A flight, and May of 1958, 4 British pilots were sent to Laughlin Air Force Base and were trained. Lots of people don't know there were other countries that trained and flew the U-2 on missions for the United States or for their country. They weren't just American pilots. May 1st, 1960, Gary Powers got shot down, but people didn't realize he'd been flying for 4 years doing those same overflights he got shot down on. He just got unlucky one day. 14th of October 1962 was the first U-2 flight over Cuba, and a little bit later than that, Major Rudolph Anderson got shot down over Cuba during the Cuban Missile Crisis. August of 1967 was the first U-2R flight, which was the full-size U-2 that they later converted to the U-2S with just a different engine, the same airplane basically. And then in 1974, a lot of people didn't realize that we had people in Taiwan flying over China. So we had a lot of Taiwanese pilots flying for the CIA, flying U.S. Air Force flights over the People's Republic of China. And they flew about 100 missions. 5 of them end up getting shot down, 3 of them were killed and 2 captured. But they flew for 8 years and 9 months. They were overflying China, and they got away with it most of the time. So we didn't put our people in danger, but we got the Chinese to fly for us. And but, you know, they needed that information also. So U-2s weren't flown just by Americans. They were flown by some other people also. And in March 1975, the 100th Strategic Reconnaissance Wing deployed to Osan Air Force Base, Korea. And that's a debt that still remains there. It's the 5th Reconnaissance Squadron called the Black Cats. Been there many times. There's real good shopping in Korea. One time I was there during Christmas. My daughter talked to me on the phone and gave me a Christmas list. So I had to, and luckily through the military mail you could send packages real cheap. So I think every one of her cousins got Christmas gifts from Korea that I had to pay for while I was over there. So, see, 12 August 1994 was the first production U-2S, and that had the new F-118-101, the new turbofan engine. And then in August of 2002, Lockheed delivered the first ramp jet. And so prior to 2002, all of the U-2s had steam gauges, we call them, just the old round needle gauges with needles. They didn't have the modern instruments, and by that time, private planes even had better cockpits than the U-2 did, and airliners, you know, had glass cockpits. Well, finally they got the money and decided, you know, we need a glass cockpit. So in August of 2002, they started a ramp mod, so all the airplanes that went through Palmdale for the overhaul got a new glass cockpit. So it was a big upgrade for the U-2 because you can imagine trying to watch all these steam gauges, we call them, during flight, whereas with a glass cockpit, you know, you got all the information and warnings and everything. It was a lot easier to fly. So that was an upgrade that helped the pilots a lot. In August 2025, U-2S-99 returned to service. I just found that out recently, talked to a friend of mine, and it was involved in a ground fire several years ago. So it was stored, and then Lockheed decided, I guess they said, hey, the government said, can you fix that airplane? And then they, I guess, gave them a bid what it would take to fix it. So they did fix it and put it back into service. So it just flew in August of this year. So another airplane that was out of service back in service. So how many airplanes are actually in service right now? I don't know. There's always probably 2 in overhaul, and there may be some that may be missing. And so I don't know the actual count. I mean, I have some theoretical counts, but I'm not privy to that information anymore. So next slide. Okay, here's an old U-2, one of the older model U-2s, A model probably, and I found this picture and I was showing it just so you can see when they come in for landing, they put the gear down and they put these speed brakes out to slow them down. So these are the same speed brakes that they use and the same tail wheel. That didn't change into the same main landing gear. But this airplane, the fuselage wasn't as big, so some of the control cables went through this thing on top back to the empennage back here. And by the way, most of the U-2s, there's a seam right there, so you can put a cart under there, undo a couple fasteners, and undo the whole tail section, take the engine out, and you can do the same thing up with the nose up there and take that off. So it comes apart pretty easy for those pieces. So when you change the engine, they pull that tail off. They have a cart that they take the old engine on, and it kind of slides on there with a winch, and then they winch the other one back up in there and hook everything up. So anyway, this is an old one. It just was a good picture to show you those things. Next slide. And this is a Fansong radar, which that SA-2 that I was showing you, this is what guided them. So they've come a long ways in radars. I doubt anybody, there may be some countries, some adversaries that might use these, but probably all of them have got better radars now. But that was a Fansong radar that guided the SA-2s back in the 60s. I just happen to have a picture of it, so I'll put it up there. Next slide. Okay, this is a picture of Gary Powers' U-2A after being shot down in the USSR. And I don't know how this picture got back to us, but I found it somewhere. And so you can tell there wasn't a whole lot left of it. And I'm sure that they were trying to see, what kind of secrets they could steal. But to be honest with you, the U-2 is a real simple airplane made all of sheet metal, and it's not it's a good aerodynamic design, but there's not a lot of whiz bang stuff in it. Really, it's just real simple. It just does the job. It's a like a truck, kind of carries a payload, and it has a pressurized cockpit. But it's compared to most new airplanes, it's a real simple airplane. Next slide. Okay, at some point they actually carrier qualified. They call them a U-2G that had the tail hook on it, and U-2Rs were carrier qualified, and they never actually used them off of a carrier because they take so much room. I mean, you can't fold the wings up on them, and they take up the deck space. So, and if you Navy guys know anything about carrier operations, you don't want something like that on your deck. So, what they actually would do is, if there was a place they needed to overfly, and it was a long ways from whatever land base the U-2 was at, they would put them on a carrier, get close enough within range of the U-2, launch them off the carrier, then they would fly and do their reconnaissance mission, and then fly back to a base. But they saved fuel by getting closer on one leg of the flight. So I don't know that they've used that much, but it has been used, and they actually did carrier qualify and land some on it, but I don't know that they ever did that. But like I say, the CIA did launch several missions from carriers because they needed the range to get there and back was too far. So they said, well, let's get you on a carrier, get you close enough where you can go overfly, get the information, then fly to a land base. But if they got them close on a carrier, and whether they do that or not, I don't know, but it's still an option, I would assume, if they needed it. Next slide. Okay, this is a pilot you see in his space suit, same as the NASA astronauts, and you see he's got what we call a PSD, a physiological support guy, holding his little life support system. So he goes up with him up the stairs and straps him in the cockpit, hooks him up to the aircraft life support system, because he's been breathing pure oxygen for an hour before he even walked out there. So he has to stay on pure oxygen to keep the nitrogen bubbles out of his blood. So this guy has to follow him. They bring him out in a truck we call a PSD van. It's like a bread van. He gets out of the truck, walks a short distance to the aircraft, climbs up the stairs, gets in, and this guy straps him in, hooks up all of his communications stuff and his oxygen and all that, checks all that out, and when he's good to go, they close up the cockpit. So this is a U-2 pilot and I can tell where they're at, Al Dhafar Air Base, because I was there, because that's a temporary hangar made out of canvas. Next slide. Okay, and at one point we found out that they would keep adding things to the U-2. They keep adding wiring, and what happened was this was unshielded wiring. So after a while, the electromagnetic interference from all this wiring began to get into the sensors, and it desensitized our sensors. And so they said, well, you got to do something about that. So we did some tests and saw how bad it was. So then we went out, and the first thing I did, we put aluminum braid on all the cables, signal cables that went through the U-2. Well, that was kind of heavy. And so I actually worked on this project, and so we found this manufacturer that could take nylon braid and aluminize it, put metal particles in it, and then braid cables with it, and it was real light. And so eventually we changed all the cables out in the U-2 that had good EMI shielding, yet, but they were lighter than the old ones that had braided aluminum on them. And so what we're doing here is we went into an anechoic chamber, the Benefield anechoic chamber out at Edwards Air Force Base, and it has all these cones all over that absorbs all the energy. So once they get in there, put all these cones in place and close the door, it shuts out any RF energy from the outside world. So you can put receivers and stuff in there and turn on systems in the U-2 and see if they're emitting anything. So that's what they were up to. They were checking to see how well we did on the redesign of the wiring to see if we knocked down some of those things that were interfering with our own sensors. And it turned out that we did a good job. And I was a part of that. Next slide. This was a Global Hawk RQ-4, and it was made by Northrop Grumman. And it was supposedly going to take the place of the U-2. Well, it turns out couldn't fly as high, couldn't fly as long, and things about it just wasn't as good as the U-2. So I can't remember how many of they built. They flew them for a while, and they finally discontinued them, and they went away. They only lasted about 2 years, and that was Northrop Grumman's bid to take over the mission of the U-2, and that didn't work out. So they terminated, and they're no longer around, and the U-2 is. And last I heard, they have 2 more years to go, and could be more than that. You know, it just depends. Because I don't know of anything else right now that can really take their place. So I think that's next slide. Oh yeah, there's a few more things. Okay, this is some personal experience here. I'll have to read it in a minute, but basically, when 9/11 happened, I was at Beale Air Force Base, and I'd gone down to Palmdale, California, to a meeting, and that's where Lockheed was based. But they also had an Air Force det there, and so we were at one of our monthly planning meetings, you know. And I was the representative from Beale Air Force Base. So we got there. All of a sudden, we find out 9/11 happened. So they said, the guy comes running in the room. Hey, they just crashed a plane in the World Trade Building. So he locked us all down for about 3 hours, and we go, well, what are you going to do with us? You know, we've got to leave. I'm not staying here all day. So finally they said, well, I guess we can let you go. But I was living in Palmdale, California. This was down in Burbank. So I had to, luckily I had rented a car at the airport in Burbank. So I thought, I'll just drive my rental car back to Sacramento, where my car's parked, 7.5 hour drive. So I drove that car back home and turned it in and got my car. And then, let's see. So I drove back home. And then the next day, after I got back home, I returned to Beale Air Force Base. Well, they were all in a panic there, so they had shut down. I lived in Grass Valley, California, on the back side of the base, so I could go in the back gate. Well, because of 9/11, they closed all the gates, so I had to drive all the way around to the main gate, which was 15-minute, 20-minute drive, and then everybody else was at that gate, and they wanted 2 forms of ID, and they were randomly searching cars, so it took me about an hour and a half just to get in the gate. And so that's what happened after 9/11. So then I get there, and finally what they decided is they told me, well, get your stuff together because we're fixing to deploy to the United Arab Emirates in Al Dhafra Air Base in the United Arab Emirates. So we went and they gave us all the military shots that we didn't have, yay. And one day I got a whole armful of shots, and they issued us steel pots, flak vests, some coveralls and stuff like that, and all the field gear that the military uses for some reason. And so then we, next day we got on a C-5, and if any of you ever have been in a C-5, we put all of our equipment in a box, huge, the bay in there is, but up by the tail there's a little section up there that you can fit about 25 passengers. So they set us up there. You climb that. We had to take all of our gear, climb these ladders all the way up to the top of the C-5, up into this area in the top, and that's where we sat for hours and hours and hours flying. We didn't know where we were going. You couldn't see anything. There's no windows, nothing to do. Luckily, some of us brought books. So we finally we landed at Dover, Delaware, and they took us to a passenger's lounge and just left us there. No food, no nothing. The next morning we ate breakfast, got on the plane again. Then we went to Morón, Spain. Same thing happened. The pilots leave us in there with no food. We finally ate breakfast the next morning, and then we ended up going and landed in Al Dhafra Air Base, where we started running missions, against the bad guys. So they, like I say, they issued us flak jackets and helmets, and we were, and we worked really long hours there. I mean, we got there, we slept in tents, and it was 120 degrees there, but the tents were air conditioned. But if the air conditioners went out, you knew it immediately. But it was good. But we had to wear the flak jackets and steel pot in 120 degrees with blowing sand, so it wasn't a fun place to be. And so while we were there, we launched an aircraft out one morning or one afternoon, and it was aircraft 1082. And while descending for landing, around the Aldofra Air Base. It's out in the desert, and there was a lot of big sand dunes. So the pilot was coming in at night after a long mission. He's probably real tired, and he probably couldn't see very good. Well, he crashed into a sand dune and destroyed the airplane. It killed him and destroyed all of millions of dollars worth of reconnaissance equipment. And it's a Major Dwayne Dively, doing fairly well. And so and when returning back to Beale, I met with his wife and talked to her a while. And I was in the Aero Club there, and so she was taking flying lessons. She said, well, my husband loved flying, so I want to see what it's all about. So she started flying, so it gave her something to do, keep her mind off things. I left the U2 program at the end of 2009 and moved to a different reconnaissance platform in 2010 until I retired in 2017. So between 2010 and 2017, I was deployed about 6 months out of the year on a classified airplane, doing classified stuff in different places all over the world. Not some real not fun places like Afghanistan. I spent a lot of time in Afghanistan and armpits of the earth, what I call it. But it paid well. So anyway, my wife liked the paycheck. She didn't like me being gone, but she didn't mind the paycheck. So next slide. And this is the crew, the contractor crew when we were at Aldofra Air Base. And I am right under the intake there, right? That's me right there, here in the back. Next slide. And this is where we stayed at Aldofra Air Base. It was a lovely place, let me tell you. And so we found out that there were 5-star hotels in town. So we said, you know what? According to our contract, we're supposed to be staying in hotels. We're not supposed to be staying in these tents. Well, that trip we didn't, but when we came back, all the contractors said, you know what? We're going to hotels. Here's our contract. We're going to go. Lock us up if you want to, but we're out of here. So we went, stayed in 5-star hotels, got per diem, ate gourmet food, and came back to work every day and did our job. While the Air Force guys had to stay in these tents in the desert here. Next slide. And this is the team that I was with there in Aldofra. This is the Air Force crew, and these are the contractors here. And that's one of the. Yeah. Oh yeah. Yeah. Where there's a lot more to it than you think. When you're deployed by yourself, you have to have all the spare parts, and you have to be willing to fix any and everything. So there was this, like I say, a bunch of Air Force guys, and then us scumbag contractors, they used to call us. But they used to call us that because we made a lot more money than they did. And I think there may be one more. Next slide. No, that was it. So anyway, that's all I have. Anybody have any questions? Yes, sir. Exactly. Yes, absolutely. Yes, sir. The SR-71 was still in use. Lockheed built the SR-71 and overhauled them and maintained them, but I was never on missions with the SR-71. There was another group that did that, but they would do long-range missions because they were so fast, and so I was never involved with that. But they were still flying at that time.
And the surface-to-air missiles that you talked about that they flew around, was that no concern to the SR-71?
Pretty much not. They flew so high and so fast. By the time they detected them, they were already gone. They probably did have some that could, if you had a bunch of radars and you knew they were coming and which way they're headed, you could get something up there that might have hit them. But I never heard of one that got shot down because they were flying 3 times the speed of sound. And I knew several SR pilots. There was a pilot and a reconnaissance system operator in it, and they said their only limitation, they could pump the throttle up and go even faster. In fact, the faster they went, the less gas they used. So if they were low on fuel, they would kick it up. But the problem was the windscreen would start glowing red and get so hot that they couldn't stand the heat. So that was their limiting factor. It wasn't that the plane couldn't go fast. It could go real fast. It could go over Mach 3. How much over it, I don't know, but after the windshield started heating up, the pilots couldn't stand the heat. They didn't have enough cooling, so it was a very fast airplane. They say Mach 3 plus, so who knows how fast it really went.
Flying at, 70,000 feet or something?
Yeah.
It would seem to be so cold that you have to have a special, you couldn't use regular JP4, or did you have special fuel?
No,
Or did
they did have special fuel. I can't remember the name of it. It was special fuel, yeah. And of course, they were in spacesuits the whole time, and there was a pilot and a reconnaissance system operator. And the early days, they had A3s, I think they call them. Or, anyway, there was a single seat like SR-71 that they flew. So that the CIA flew, but when the Air Force took it over, they go, oh no, we need another guy in there. You know, we can't have one guy flying by himself. So they put an extra seat, which it really, he was a reconnaissance system operator, so it took some of the workload off the pilot because a lot going on when you're going that fast. So anyway, any other questions? Yes, sir.
Aerodynamically is what a spacecraft experiences when it leaves the gravitational pull of the Earth. They call it maximum Q, maximum dynamic pressure. Is that related to that coffin corner?
Yeah. There's a the Earth's gravity, the atmosphere, the air friction, all those things are factor. And like I said, the SR could go faster, but they got so hot the pilots couldn't stand it, so they would start glowing red. So the limitations were the environment they flew in. The U-2 it could only go so fast. It wasn't real fast because it had such huge wings and a big cross section. But the SR-71, they called it Mach 3 plus, and they never really said what the actual speed was. But pilots I've talked to said they go well over Mach 3, but they couldn't do it for very long because the heat would get so bad they couldn't stand it. So. Huh?
Did they make you sign an NDA when you left employment?
Yeah. Oh, yeah. Several of them. I've signed lots of those. I was on a program even more classified than this that I can't even tell you anything about. Yes, I would be shot. So, any other questions? Or I would just disappear.
Do other countries have equivalent aircraft for this purpose? How does U-2 compare to theirs, do you know?
Yeah, there are. The Russians and some other countries have something equivalent to the U-2. I don't think they're as good, but there are other countries have high altitude reconnaissance aircraft. And then they depend a lot on satellites, but the thing about satellites, they're either in a elliptical orbit or they're in a geosynchronous orbit, and if something happens, when you put them up there for a certain reason and things change, you can't move them you can move a satellite a few times, but once you expend the fuel, you can't move it again, and if it gets in an orbit that's starting to decay, it'll eventually fall out of the sky. And that's why reconnaissance assets like the U-2 are still important, because satellites, they can't be everywhere, and you can't move them around much. So they're very good, and they give us a lot of intelligence information, but they're not that flexible. Yeah. Any other questions? Yes.
You showed the picture with all the different antennas, and maybe I missed it, but how many total radios or receivers were on the plane?
I don't remember, but I think there was something like 20 different receivers, VHF, UHF receivers, and then you had the radar receivers that received all different 6 or 7 bands of radar frequencies or other high frequency things. So pretty much anything that we knew was out there, if they didn't have an antenna on the plane, they would put one on for it.
Sorry.
No, go ahead.
They played nice with each other, even with all the shielding?
Well,
Did you have to turn some off to use the others?
no, there was blanking. So like when you sent out a radar signal or an IFF signal or something, you blank the receiver so it didn't overload it. Or when you communicate on the radio, you would blank the VHF or UHF receiver. So they had blanking circuits that were all tied in so that you didn't saturate a radio or blow out a radio like that. So that was something we had to work on, was interoperability of things.
I would regret asking this, but what is synthetic aperture radar? See, I knew I'd regret it.
I don't know if I could explain it. It acts like it's a big radar. It has a big aperture when it's not a big radar. So by some sort of electronic trickery, they can make it look like a real huge radar antenna, but it's really not. So that's why they call it a synthetic aperture radar. It's some kind of technology that gives them what appears electronically to be a bigger antenna, but it has to fit in that nose. I mean, there's a constraint there. So that's my understanding of it. I'm not telling you that's 100% correct, because I don't know everything about it, but I know 90% of it. So.
I just always heard that term, but
Yeah.
I didn't know what it really meant.
When you were
showing the slide for the anechoic chamber. Did they operate the engines during that?
Oh, no.
No, that would have been disastrous.
Were the engines a source of interference of any?
No, possibly the generator was, but anything they put on the airplane had to be qualified for electromagnetic interference, and so before they put anything on there, it had to be tested, and they knew what kind of radiation it might put out, and they would shield it somehow where it'd be protected. But then at some point, we had to go back and go, okay, we've got too many things that are interfering, so we had to go redesign all the wiring and shielding and stuff like that. And that's why
The requirements be significantly different than for commercial?
well, yes, because on the U-2, weight is at a premium. So every pound of weight takes more thrust to get to altitude. So what we ended up with some aluminum shielding, and that didn't work. So what we finally did was we took braided nylon, impregnated it with some sort of conductive material. I think it was some sort of aluminum, but I'm not sure what it was. And we found out that material worked really good for shielding. The bad thing we found out later was that if you touched something electrical that was hot with it, it would arc and it would melt it, and if that stuff dropped on you, it'd burn you. So a few maintainers found out the hard way, be careful with this stuff that looks like cloth. It isn't, it's conductive. So, yeah.
With oscillators and the radios, the crystals are oscillate. Did y'all have to fight temperatures, or were they all heated?
No, they were in pressure. All the radios, things like that, they were standard aircraft radios, but they were in pressurized areas of the aircraft. Yeah. They were just standard RT, whatever they were. You know, they had a UHF radio and a HF, UHF, and VHF radios, the same that the rest of the Air Force used. They just had them in a pressurized area. So, standard mil-spec radios. Yes, sir.
Did you ever see a KWM-1 in the back of a U-2?
I couldn't say. They had all kind of crypto devices. Of course, the data links had all kind of crypto devices on them. So, you know, they would load crypto on the airplane before it took off, and the ground station would have to load crypto too to talk to the airplane. Every now and then they would lose their crypto on the airplane, and when they did that, you had to come back. But pretty much it. And they had paper. I can't believe they did it this way. They had a paper tape reader, so you'd get this little box and you'd pull this paper tape thing through there, and you'd plug it in the airplane, push a button, and that would load your crypto. That's the way we did it. I guess that's what they gave them, and they used it, and it worked. So, yes, sir.
Did the cockpit have some kind of shielding to protect the pilot from all that radiation from all those radiators?
It was all aluminum, and then they were in a spacesuit. But most of the radios were receivers, you know, except for the ASARs in the nose. But it was tightly focused in like a microwave beam out, and they tried transmitting as little as possible, because when you're trying to stay anonymous, you don't want to be transmitting anything. So they maintained radio silence most of the time. Although the data link was there, but it was all encrypted microwave stuff. But now, as far as I know, that wasn't a real problem. Probably they got more radiation from the sun because they were so high above the atmosphere than they did from anything else. I've heard that some pilots had problems with that later in life. Because, you know, if you fly thousands of hours up at the high atmosphere, you're getting some radiation from the sun that could be dangerous to you. So, any other questions?
What was the operating tempo? How busy did you keep an aircraft?
Well, when you're deployed, you flew 2 flights a day, sometimes 3 flights. You'd maybe 2-day flights, 1-night flights, quick as you could turn them. And the warfighters wanted that intelligence. They want something airborne all the time. And sometimes you'd get troops in contact, and you'd have to launch an airplane to help them out.
You talked about the airplane being very, very simple.
Mm-hmm.
I guess that would contribute to having a really low maintenance hours versus operating.
Yeah, actually, there was an autopilot that had a little servo, but all the control surfaces were all controlled by cables and pulleys. It was just a simple. Everything on the U-2 was like 1950s. I mean, as far as flight controls, 1950s technology with just some servos on. There was no fly-by-wire anything on it.
Looks like a glider.
Yeah, well, it could glide a long ways, yeah. They've had some of them flame out and glide, 30, 40 miles back to base, yeah. So, any other questions?
Did they always use it just to aid in the military, or did they in surveillance, or did they ever use it like you hear like with their Super Bowl or something going on? They
No, you don't use it for anything civilian. But it's always gathering intelligence, whether it be in wartime or peacetime. So there's ships at sea, there's military bases around the world, and you want to keep an eye on what these people are doing, what kind of communications they're using, what frequencies they're using. So you're always flying and you're collecting everything. You may not be able to decrypt it or decode it or whatever, but they send it back to the National Security Agency, and that's what they do. So if they don't know what this signal is, they can tape it or they store it, and then they go back, and different intelligence agencies can take that and break those codes, because it's most all the communications are encrypted, and they change encryption a lot. And so that's a cat and mouse game where you can receive information, and if you know how to decrypt it, you can decrypt it in real time. But if they give you a new encryption, you've got to record it and get somebody that knows how to decrypt it, which there's government agencies, that's what they do, but you got to wait till they get that done before you can decrypt it. So that's a cat and mouse game where you're always, it's a constant battle between, do I know how to encrypt this data, or I know what it is? And then if you decrypt it, like I said, it's going to be probably most time in a foreign languages, and every now and then you get some foreign languages that there's maybe not too many interpreters. So interpreters are in big demand in the reconnaissance arena, because you get, when you're in some foreign country, and they have language schools that they send military interpreters to that do that kind of thing. But they're the ones who have to interpret what's going on, because once you decode it, it's in a foreign language that everybody can't understand 10 different languages. So they have a lot of linguists.
TARC 71 was flying. Were they doing different missions than what that was?
I'm not really sure. They have similar missions, but usually they were more long-range, quick flybys, where the U-2 would stay on station for like 10 hours, continually gathering data for the war fighters in real time. And the SR-71 was surprising people in gathering data that was gathering intelligence data, like maybe this was a new communication system or a new radar that you happened to catch them transmitting because they didn't know you were coming at Mach 3, and you caught it for 2 or 3 seconds or a minute or two. The U-2, they knew you were there, but they didn't necessarily know what you're doing. Some countries, some of the third world countries, they didn't know what you're doing, but the SR-71 would sneak up on people because they were going so fast, and maybe catch a snippet of some new encoding scheme or something, and they would take that data back and then use it to decrypt it and learn how to decode that particular whatever. So they were good for that kind of thing. Yeah. Any other questions? Well, appreciate you letting me do this. I enjoy it. My memory, my short-term memory is really bad, but my long-term memory is not too bad, and I had my notes from last time, so I was able to remember most of it.
I hope you won't wait 3 years before giving us.
Well, I could be talking to you.
Well, thanks, Joe. It's been 3 years, but it was well worth the wait. So thank you again. I think everybody enjoyed it. Let's see. One brief note before we leave tonight. You may have noticed the deal with the door there. The facility here has I'm sure I meant to mention this earlier, has a new policy that requires the exterior doors to be locked and closed at all times. And so that's a new thing for us this month, and so that's how it is. That's why that is. With all that, thanks for being here, and we'll see you next month, which is, as far as I know, going to be here, same time, same place. Everybody go play radio. It's a lot of fun on the airwaves.